Hey everybody, Mr. Judson here. Hey, just one quick thing. Really want you guys to read the messages that I put at the top of that document that's labeled Judson's videos. That will change every time I upload new videos. If there's a quick word I have to get out to you, that's where you'll find it. So please read those. One of the most important things is when you're looking at the YouTube videos, I want you guys to click on thumbs up if everything makes sense. Give me thumbs down if you don't understand and it doesn't make sense. This is feedback to me that's going to help me know whether you guys are understanding what I'm trying to get across or not. So real important, it's not whether you like it or not, it's does it make sense to you? Are you understanding what I'm trying to explain? And don't feel bad clicking a thumbs down. It's, like always in the classroom, I'm just trying to help this stuff make sense to you guys. So let me know. That's a very important piece of communication for myself. Yeah, also, I'm going to be putting documents right before the one that says Judson's videos that will be answer keys to all the even problems. This, again, is just to give you guys some feedback and help you, make sure you understand. All right, so for today, what we want to do is we want to look at geometric sequences. And they're a little bit different than the arithmetic sequence. If you notice, I'm not adding the same number each time. But if you look closely, you could see that what's really happening is we're multiplying by 3 to get to the next term. And so in a geometric sequence, we want to multiply by the same number to get the next term. And so that's what we're doing here, is we're multiplying by 3 to get to the next term. So back to our elementary school kid, that teacher was just looking for a way to get him. And so what he thought is, all right, instead of adding a number each time, we'll multiply. Because that way these numbers eventually will get very big. If I'm multiplying by 3, my next number is going to be over 150. And so there's no way that little kid could add those numbers up that fast. But as we already know, this little kid was a little different. He figured some things out. So this right here would be our first term, second term, third term, and fourth term, and so on until we get to the nth term. And so our first question here is, how do you find the nth term? If I said, let's just keep on going with this pattern, I want you guys to find the 27th term, how would we do that? Well, kind of like with the arithmetic sequence, we have a place where we start, which in this case is 2. So I would say that a sub 27 is going to equal, we're starting with 2, but this time we're multiplying, and we know we're multiplying by 3, so how many 3's am I going to multiply by to get to each term? Well, to get to the second term, I only multiplied by 3 once. To get to the third term, I multiplied 2 times 3 times 3, so I multiplied by 3 twice. And to get to the fourth term, I started with 2 and I multiplied by 3 once, twice, 3 times. So for the nth term, you guys should already be thinking this in your head. We're multiplying by how many 3's? And it should be n minus 1. So what we want to do is we want to come up with a formula here. So our formula, we're saying to find the nth term, I'm going to start with the first term, a sub 1. I'm going to multiply, in this case, by 3, but we need to know what to call that. And what we're going to do is we're going to call that the R value. That's what our book calls it, and so we'll do the same thing. So we're going to take the first term, I'm going to multiply it times r, and the number of times we're going to multiply by that is one less than the term we're on. So r raised to the n minus 1. Remember, an exponent just means you're multiplying by this number over and over again. How many times do you want to do it? Well, one less than the term we're looking for. So in this case, since n is 27, we really want this to be 26. And we're not going to be able to do that in our heads. We're going to have to go to the calculator. I know, again, you can't see this, but if you do this along with me, we should get the same answer. So I've got 2 times, I'll put this in parentheses, 3, raised to the 26th power. And what I got is a very big number. This equals 5.084 times 10 to the 12th power. Remember, on our calculator, when they say E12, that means that's the exponent for 10 raised to whatever. So if I was to take this decimal point and move it in the positive direction 12 places, 1, 2, 3, and I still got 9 more to go, that means that this answer is in the quadrillions. It's a huge answer. But this is the best way we can write this when those answers get large. So one of the things that you see here is that we don't really want this number to get very big. It's probably not long until our calculator can't even deal with it because the answer got so large. Okay, so here's one for you guys to start with. Our first term is 8. Our r value is 3/2, and they want us to write the first 5 terms. You guys go ahead and do that real quick. Alright, so here's what I got. First term is 8. I now want to multiply this by 3/2. So if I did that, think of this as 8 over 1 times 3 over 2. That'd be 24/2, which would be 12. And then my next term, I'm going to multiply by 3/2. So 36 over 2, that would be 18. Now multiply by 3/2 again. That would be 54 over 2, which would be 27. And now I think finally our next one will become a fraction. If I multiply this by 3/2, I get 81 over 2. And if you listed that as 40.5, that would be okay as well. So there's the first 5 terms in this geometric sequence. Now, let's try and find the 10th term. You guys go ahead and try that. The 10th term. Alright, so using our formula, I've got a sub 10 is going to equal my first term, which is 8. I know what I'm multiplying by. It's 3/2. And I want to raise that to the n minus 1. So 10 minus 1, that would be to the 9th power. And so if I did that on my calculator, you can even call this 1.5. So I've got 8 times 1.5 raised to the 9th. And I got 307.547. Or I could try and convert that to a fraction. So if I go to the math button, choose option 1, convert to fraction, what I got was 19,683 over 64. This would be my exact answer. And I'm okay with either one. Choose either one of those. So here's another problem. We have a geometric series, or sequence, and it's 16, 24, 36, 54, and they're asking us to find the r value. You guys go ahead and try that. All right, so some of you may look at that and go, 16 times what equals 24? I don't know. Well, let's write it out. 16 times what number equals 24? You know, once you see that, you realize, well, that's not a very hard equation to solve. I just got to move 16 over and divide. So r is going to equal 24/16. And if I reduce that fraction, I can divide top and bottom by 8. I would get 3/2. So there's my r value. So now what I want you to do is to find the 12th term. You guys go ahead and do that. All right, so once again, we just use our formula. A sub 12 is going to equal our first term, which is 16, times 3/2 raised to the 12 minus 1, so to the 11th power. And so I'll go to my calculator. I've got 16 times, I'll call that 1.5 again, but you can put it in as 3 divided by 2, and then raise that to the 11th power. And so what I got for an answer is 1,383.961. We'll try to convert it to fraction, and we'll see if it works. In this case, it didn't. That doesn't mean that there isn't a fraction for that decimal number. It just means because that exponent getting large and this thing increasing really fast, it wasn't able to do that. So that's okay. We'll just go with the decimal version, and that will be our answer. All right, so you probably know what's coming next. That teacher wanting to stump this kid said, all right, now add up the first 12 terms. Well, that's a little more difficult. And I think this kid might have been stumped for a while, but not for long. There is a formula. I'm not going to show you how to get the formula just because of memory issues. I'll write it down and we'll go ahead and work with it. But there is a formula for this. All right, so here's the formula. And like I say, this is a little more complicated to show where this comes from. But if somebody's interested, you know, you could just Google, how do you find the sum of a geometric sequence, or what's the proof of the sum of a geometric sequence? And the steps aren't hard to follow. I think you would be able to understand it, but you could do that if you want. All right, so here's our formula. If I want to add up the first A terms, this is saying take the first term and multiply it by 1 minus r raised to the nth divided by 1 minus r. So let's say I have a geometric sequence that looks like this. I believe I'm on number 4. I've got 3, 6, 12, 24, ... And we want to find the sum of the first 20 terms. Well, using this formula, I would just say that the sum is my first term, which is 3, times 1 minus, all right, so what's my r value? What am I multiplying by each time? Looks like r equals 2. So I've got 2 raised to the n power, which is the 20th power, over 1 minus 2. All right, so this would be 3 times 1 minus 2 to the 20th power. 1 minus 2, that's just a negative 1. And so I just have to figure out what that is on the calculator. So I'm going to do 1 minus 2 to the 20th first. hit enter. I got a negative, what is that, 1,048,575. I'll divide that by a negative 1, which all it does is make that number positive. So divided by a negative 1, and now times 3. And here's what I got for my answer. I got 3,145,725. 3,145,725. There's the sum of the first 20 terms. All right, so here's another geometric sequence, and we're being asked to find the 15th term and the sum of the first 15 terms. You guys go ahead and try that. All right, so first of all, I have to figure out what my d value is. And again, if you're not sure, just say, start with your first term, 4 times r equals 2. Divide by 4, you get r equals 2/4 or 1/2. And so you might look at that and say, well, wait, we're dividing by 2 each time, but that's the same as multiplying by 1/2. 4 times a half is 2, 2 times a half is 1, 1 times a half is 1/2, and so on. So now what's the 15th term? Well, a sub 15 is going to equal the first term, which is 4, times our r value, which is 1/2. N minus 1, that would be 14. And so if I go ahead and do that on the calculator, I've got 4 times 1/2, I'll go 0.5, raised to the 14th power, and I get some decimal number. I'm going to see if I can convert it to a fraction. And I can. I get 1 over 4,096. So now what would the sum of those first 15 terms be? Well, based on our formula, we've got the first term, which is 4, times 1 minus 1/2 raised to the 15th power. So I should put that in parentheses. And then divided by 1 minus 1/2. So let's see, I'm just going to do this denominator real quick. I get 4 times, I still have 1 minus, I'm going to call that 0.5 raised to the 15th. 1 minus 1/2 would be 1/2. Or I could call that 0.5. Might make it a little easier to punch that into the calculator. Alright, so I'm going to do this denominator, or this numerator first, and then I'll divide by 0.5. So I've got 1 minus 0.5 raised to the 15th. I got 0.9999694, so really close to 1. Now divide that by 0.5. So now I got 1.9999, so really close to 2, times 4. And there's my answer. I got 7.9997, so if I round that off, I guess my answer is 8.00, about 8. There it is. If I try to convert to a fraction, I got this fraction right here. 32,767 over 4096. Which, just looking at that, 32 divided by 4, that's pretty close to 8. Alright, so that's all we have for today. So this would be our third assignment. It's on page 669. We're going to do 1 to 39, every other odd. And I will see you guys on Thursday. Don't forget, thumbs up, thumbs down, and don't forget to read the messages up above where the assignment is given. You guys take care.